Hello, I am Professor Shalini Sahay from EC Department of SIRT. Today, I am going to discuss about the convolution in this lecture. First, we'll discuss about the superposition and time invariance property. Here, the basic signals in the form of discrete signal is given to the discrete time linear time invariant system. Xn represents the input of the system, whereas the Yn represents the output of the system. We can represent any signal as a linear combination, which means that it can be represented in the form of weighted sum of the inputs. The response of an LTI system to these basic signal is easy to compute and previous significant insights. For LTI system, there are two natural choices for these building blocks. Here, we have taken as the discrete time systems in the form of unit impulse function. So del n, which is shifted by n naught. Whereas in continuous time system, we have taken the impulse and n is replaced by small t, which represents the continuous time signals. Now, the response of a discrete time LTI system, which is a property of the convolution. Here, the input is given as an xn and hn represents the response of the system and yn represents the output of the system. So here the unit pulse response, that is hn, as the response of a discrete time LTI system, and the unit pulse function in the form of del n. Now the principles of time invariance represents that if del n is the input and hn is the output response of the system, so if the impulse is shifted by k, the response will also be shifted by k. So del n minus k responds to h n minus k. Now the principle of linearity here, which is represented as xn, and we have taken the summation sign as the signals are taken as in the form of discrete time signals. K is the index parameter which varies from minus infinity to plus infinity xk and multiply with the impulse which is shifted by k. So the output yn represents the summation sign xk into hn minus k, where it is known as the impulse response of the system when the impulse is given as the input. So now this function is represented by a convolution or mathematical operator with this star sign xn star with hn, and where star means the convolution operator, and it represents the convolution sum of the two functions. Now we can say that linearity implies the weighted sum of the input signals which produce a similar weighted sum of the output signals. Each unit pulse functions, that is del n minus k, produces a corresponding time delayed version of the system, that is the impulse response of the function. The summation is referred to as the convolution sum, and this operator represents, this symbol represents the convolution. Now the LTI system and the impulse response. The output of any discrete time linear time invariant system is a convolution of the input signal with the unit impulse response. So this represents, if we give the xn and it is the impulse response of the system, so the output can be represented as the convolution between the xn and the impulse response, which is shown mathematically in the form of this below function. So any discrete time LTI system that is completely characterized by its unit pulse response. So with the help of the graphical interpretation, we have represented the different properties of the signal to the discrete time linear time invariant system. So it is an unit sample and it is Yn, which represents the impulse response of the system. This property, which represent as shift invariance, this is the scaling property, and this is the superposition property. Now we can visualize this convolution in the following steps. So what we have taken as hk, and we have flipped, which means that we have inverted this signal. So hk will be turned as h minus k. Then we have shifted at n minus k. Then we have multiplied with the input signal, and it will given by an summation k is equals to minus infinity to plus infinity xk into hn minus k. So these are the steps which are involved in the convolution, and with the operation has a simple graphical interpretation. Now we can represent by taking any mathematical function, and we will perform the convolution in the form of graphical. So this is xn, this is hn. Now what we have done, we have replaced n with a new indice factor k. Then what we have done, hn is first it is flipped to the vertical side, and then we have shifted to the positive. Now we can calculate each output point by shifting the unit pulse response one sample at a time. So we will take the different values of the k, and we will multiply xk into h minus k, and we can perform the mathematical operation of convolution between the two signals. This is how the graphical convolution is performed in xk, hk, and by taking the different values of the k and n, we have performed this convolution between the two signals. So here we have taken h, n, we have taken minus 3 minus k. In this we have taken n value as minus 2. In this we have taken the value of n as minus 1, and it is 0. So first we have what we have done, we have inverted hk, and then we have shifted hk towards the n. So now in the previous slide we have discussed that n is taken as the on the left hand side. Now we will put on the right hand side, and we'll take the positive values of the n, and we will plot the different values of h n minus k, where we have taken n is equals to 1. In this we have taken n is equals to 2. This represents n is equals to 3, and so on. This is n is equals to 4. Now with some observation has been listed that yn is 0 for n greater than 4. So if we take the values beyond n is 4, we will get the convolution between the two signals as 0. So similarly, we can define the duration of hn as the difference in the time from the first non-zero sample to the last non-zero sample. Now, the fact that the output has a duration longer than the input indicates that convolution often acts like a low-pass filter, and which has smoothened the signals. Now, these are the examples of discrete time convolution. Here, what we have taken as the hn as the impulse, and we have performed the operation yn. We have taken the summation k minus infinity to plus infinity xk h n minus k. So here the input is multiplied with the help of the shifted impulse function. Here we can perform as the unit step response of the discrete time LTI system. So yn has taken as summation of k minus infinity to plus infinity xk h n minus k, where h is replaced by unit step function, that is your u. Likewise, we have taken the examples of the delayed unit impulse function. Here we have taken xk into h n minus k, and now this hn we have taken as the impulse. So we have put the value of hn as del n minus n naught minus k. Now what we have done in this example, we have taken the integration. So xn is un and hn is a to the power of n un, and the modulus of a is less than 1. So here what we have done, we have multiplied the exponential pulse with the with unit step function. So we have taken the yn and we have performed the mathematical convolution in the two signals. Now we'll discuss some properties of convolution. First, it is the commutative property, which means that if we multiply or we take the convolution of xn and hn, so if we interchange them, so it represents the commutation property, which means that xn convolution with hn is equals to hn convolution with xn. Now the distributive property, which implies that this xn is convolute with the sum of the two functions. So we can rewrite as xn convolution with h1n plus xn convolution with h2n. So here the two functions are connected in cascades. Now this is the associative property, which means that xn is convolute with h1n, which is convolute with h2n. So we can perform with the help of associative property. Here the two functions are connected in series. So this represents the associative property. Now causality, some more property of the discrete time LTI system. Causality means that hn is 0 for n less than 0, which means that for n less than 0, we did not get any output. So the impulse response of the system is also 0 for n less than 0. Stability, which means that the summation of k minus infinity to plus infinity hk, its value should be finite, which means that its value should be greater than 0 and less than infinite. So it represents the bounded input and bounded output condition. These are the sufficient condition for the discrete time LTI system, and this is the necessary condition for the LTI system. So here xn, which is less than x max, which is less, should be less than infinity. So if we bound it, so there should be the important condition or the sufficient condition for the discrete time LTI system, that its output response should lie between these ranges. Now necessary condition, if summation k minus infinity to plus infinity h n minus k, and if we take the mod, it should be infinite, and this is the necessary condition. Convolution for discrete, by definition we know that yn is equals to hn, and if it is convolute with del n, we'll get the hn, because the amplitude of the impulse is 1. So if we multiply 1 with any input, we'll get the output as the input. So it will be hn. Remember, due to time invariance property, now hn is convolute with impulse which is shifted n minus n naught. So its the answer, or it will result in hn minus n naught, because the multiplication represents between the two signals, that is impulse with the pulse function, and it is now shifted to n naught. So we'll get the result at only at the position of n naught, elsewhere its value is 0. Now if we multiply impulse with any function which is shifted, now what we'll get is the del n, it is the multiply, and its value at g minus n naught. So these are the properties of the convolution sum which we have represented. Now we have taken the three convolution operators, one between these two signals and these two signals, and we can interchange the order of the signals, and we'll prove that this is the commutative property. And now this is the distributive property with respect to addition. So this is the shift property, convolution with the shift impulse function. So if xn convolute with del n, we'll get xn, and if we multiply by del qn, we'll get the xn minus q. Thank you. That's all about the convolution.